You can think of birds as a group of highly derived theropod dinosaurs that made it through the mass extinction event at the end of the Cretaceous. Opposite crocodilians, on the primitive end, birds are the extant bracketing taxon for the advanced or derived end of the dinosaurs. This is why we predict a biological possibility for dinosaurs as lying just about anywhere between what we observe in these two living groups, birds and crocodilians. Birds, as far as we can tell from the fossil record so far, evolved in the late Jurassic. Archaeopteryx was the first fossil bird discovered. Since then, Archaeopteryx has reigned as the oldest and most basal bird known. A couple of fossil organisms that are a few million years older have given this definition a firm working over, though. But there is still some contention over the status of these older feathered theropods, Anchiornis and Aurornis, as birds. One interesting thing about these most primitive birds, or bird-like dinosaurs, is that, rather than just having 2 wings, their legs also sported flight feathers, so they had 4 wings. Even Archaeopteryx bore feather impressions on the legs of the Berlin specimen, and a later form, though categorized as a dinosaur, Microraptor, had 4 very well-defined wings. Their tails were also long, like those of dinosaurs, and feathered. We see feathers in the theropod dinosaurs that are most closely related to birds, and evidence of feathers even where feathers were not directly preserved. The quill knobs on the forelimb bones of dromaeosaurs show where muscles that attached and manipulated long, stiff feathers, at least on the arms, are one of many similarities that seem to unite birds and these theropod dinosaurs. Their lightweight skeletons, invaded by air sacs, are similar in a number of ways. Birds, at least some of them, used to have teeth too, until the last toothed birds went extinct at the end of the Cretaceous. Birds and dromaeosaurs share a unique wrist bone as well as a bone in the shoulder girdle region called a furcula. The visible similarities between the foot bones of birds and these dinosaurs is also uncanny, and different from almost any other sort of animal. There are a few candidates outside the theropod dinosaurs that could have spawned the earliest birds. Scleromoculus is one of these outside possibilities, a lightly built, possibly arboreal reptile from the late Triassic. Longisquama is another such reptile, and it is even older than the oldest known fossil dinosaur bones, from sediments that are nearly 235 million years old in the Middle Triassic. Longisquama even bears structures that could represent the earliest stage in feather evolution, if that is what they are and they persisted to be inherited by birds. Due to the incredibly fragile nature of these little animal skeletons and the inherent imperfections in the fossil record, we cannot really say how these little animals fit into the tree of life, and cannot entirely rule out the chance that somehow birds and perhaps some other animals we think of as dinosaurs can be traced back to one such alternative origin. If birds are living dinosaurs, then are dinosaurs truly extinct? There are obviously extant or living species of birds, so those species are the opposite of extinct. It is not terribly useful to refer to them as dinosaurs, but we can think of birds that way just as we can think of ourselves as members of the Therapsid order, which includes all sorts of strange reptile-like mammals as well as all of the friendly furballs we are familiar with today. We live in the age of furballs today, or the age of mammals as the Cenozoic era is known. It began with the end of the age of reptiles, which is what the Mesozoic era is known. The geologic boundary between these two eras is well marked and heavily studied. Most of the world calls this the KPG, or Cretaceous Paleogene boundary, We like to hold on to old units here in the United States for longer than is reasonable in many cases, like our units for volume, mass, distance, velocity, and all of our other nonsensical imperial units, which the Empire did away with long ago, I might add. As an example from geology of this same behavioral phenomena, we still call the period following the Cretaceous the Tertiary period, so in the U.S., you will still hear the boundary referred to as the KT, or Cretaceous Tertiary boundary. Regardless of what we call it, this boundary was deposited 65.5 million years ago. It is a very useful boundary, geologically, because the world changed dramatically over the very short period of time over which this boundary was deposited. Below the boundary, we find dinosaurs as an obvious guide fossil in terrestrial deposits, and a number of marine reptiles and amniote species in marine sediments. Above the boundary, these fossils are gone. 2 out of every 3 species disappear at this boundary. Such a major loss in biodiversity is called an extinction event. We count 6 of those in Earth's history, including the Holocene extinction in which we are currently living. The one at the end of the Cretaceous was the second largest measured in the fossil record so far. The most massive extinction event wiped out 9 out of every 10 species, and that was at the end of the Permian. It was that extinction event that gave rise to archosaurs, or at least gave them a chance to proliferate. It takes something special to cause an extinction event, a global disruption in the equilibrium normally sustained across the planet's biodiversity. A few hypotheses were floated over the course of the 20th century, with volcanism being the most likely culprit for some time. The Himalayan region experienced extraordinary volcanic eruptions near the end of the Cretaceous as India approached southern Asia. The massive lava fields known as the Deccan Traps were formed then. The timing of this event was not quite right, though, as the activity seems to have settled down entirely for hundreds of thousands of years before the extinction event occurred. In the 1980 publication of a paper called Extraterrestrial Cause for the Cretaceous Tertiary Boundary Extinction brought to light an exciting new idea. If you've seen the movie E.T., then you know where I'm going with this. Clearly, alien headhunters discovered the great trophy animals of Earth in the late Cretaceous and hunted everything that looked good as a taxidermy specimen. Or maybe not. Instead, what the paper pointed out was that the boundary marking the end of the Cretaceous exhibited a massive spike in the amount of a rare earth element called iridium. Most of Earth's iridium is in molten form at the center of our planet due to its high density. That also happens to be where most of our gold is. At Earth's surface, iridium is quite scarce. The presence of this spike suggested the sudden introduction of a new source of iridium, the most likely of which was the vaporization and sedimentary dispersal of a massive asteroid. As soon as we knew what to look for, the corroborating data started to pour in. Tsunami deposits, the likes of which would be generated by the oceanic landing of a massive asteroid, were found in Cretaceous deposits. Shocked quartz, a phenomenon that otherwise has only been observed associated with nuclear weapons tests, was also found in this stratum. Petroleum surveyors had, of course, found the crater years before the world began looking for one. Since their data is proprietary, though, the discovering scientists were forbidden to share their data, showing the circular pattern that seemed to mark a massive impact. Tektites, droplet-shaped nuggets of remelted rock hardened in the sky they were cast into before falling back to Earth, seemed to have a pattern of abundance radiating from this region in the southern Gulf of Mexico, just off the Yucatan Peninsula, where the crater has been found. All of this suggests that the asteroid impact theory of mass extinction is the most likely culprit. The impact and the ensuing cataclysm would have been the last sight of the world's dinosaurs that were alive at that time. Tyrannosaurus rex, Triceratops, Edmontosaurus, Struthiomimus, Pachycephalosaurus, Thescelosaurus, Dakotaraptor, to name a relatively new one. These animals, along with around 65% of the world's biodiversity, were wiped out, if not during the violence, then shortly following it, as the inhospitable changes turned the world into a place in which dinosaurs simply could not persist.